Hey everybody. So someone asked me to do lesson 8.5, and since I have not done that yet, and someone's requesting it, here we go. All right, so I'm in unit 8, and this is lesson 5 on triangle proportionality. All right, so basically we're setting up proportions of two triangles and cross multiplying and solve. That's middle school type stuff. In high school, you have a triangle sitting in another triangle with lines that are parallel. Now that brings up a whole different set of rules. So if you are with me in 8.5, the first thing you're going to see are what those rules are. So let me explain. In middle school, you have triangle, one smaller than the other. You set up a proportion based on their segments that are the same proportional, and you cross multiply and solve. But in high school, you've got one inside the other one, and then you've got parallel lines. Well, what that means is if the lines are parallel, then their sides are proportional as well. So what I mean by that is BP, which is the left side of the small triangle, in middle school has to be set equal to BC, which is the left side of the big triangle. And same thing on the right side. BQ, which is the right side of the small, has to be in proportion to BD, which is the right side of the big. But since the lines are parallel to each other, that's what those little triangles mean, then I can set BP in proportional to PC, which is not even the side of a triangle. And I can set BQ with QD, which is the right, but it's not the side of the triangle. So this is what this lesson is really all about. And if you can set them proportional, then that means the lines are parallel. That's what the converse here is saying. Okay, so we're going to get right on into it. Example number 1 on page 487 of your consumable workbook, page 487. I'm on example number 1, so let's just get on into it. All right, so it says in triangle BCD, which is the big triangle, PQ is parallel to CD. That's what that little skinny 11 means. QD is 14.5. BP is 9. PC right here is 15. We want to find BQ. Well, they actually went ahead and set this problem up for you, which is super nice. So they said that the left BP is going to go with the left PC. That's what's going on right here. And they're going to do the right side. BQ is going to be with the right QD. And that's what this is over here. So top with the bottom equals top with the bottom. All right, so our BP, according to the problem, is 9. You know what? If you're a visual person, you're probably sitting there lost already. Let me open this up and show you guys, because I'm a very visual person, and I totally get it. All right, so let's go back to this. All right, so it says QD is 14.5. So here's my 14.5. And that's from Q to D. BP is 9. Whoop, pop, there we go. PC is 15. And they're asking us to find BQ. There it is right there. All right, so that if you're a visual person like myself, it doesn't hurt to kind of put this stuff in. All right, so left goes with left. 9 goes with 15. Right goes with right. The unknown goes with 14.5. And then, of course, they're going to cross multiply and solve. All right, so let's do that. Let me go back and erase this because you can't see it. All right, so we're going to cross multiply and solve. And that means I'm going to multiply 9 times the 14.5 and then BQ times the 15. Well, it did that part for us. BQ times 15 is 15 BQ. And if you multiply 9 times 14.5, you're going to get 130.5. And of course, the opposite of multiplying is to divide. So divide by 15 on both sides. And 130.5 divided by 15 should be 8.7. All right, there's your answer for example number 1. Okay. Hope everybody's okay so far. If not, ask me a question. I'm going to get this so I can scroll down a little bit. All right, I'm on the check. And it looks like it's the same type thing. All right, but I'm a very visual person, so it says triangle FGH. These lines are parallel. Again, that's what that little skinny 11 means, and that's what those symbols right there mean. All right, we got G to B is 14.4. All right, that's the left side of the small triangle. BF is 4.8. All right, GH. Oh, okay, hang on. We got a trick right here. G to H is the big right side of the triangle. So G to H is the right side of the big triangle, which we do not have on this side. Now they want us to find CG and they want us to find CH. Okay, so what I'm saying is why this is a trick is because I don't have anything really to compare here until I can compare GH, which is the right side of the big triangle, with GF, which is the left side of the big triangle. So I need to add these two parts together, the 14.4 and the 4.8. So I've grabbed my calculator and I'm doing that. So the whole left side from G to F is 19.2. So listen, I can only compare apples to apples and oranges to oranges. I can only compare, the whole right side of the big triangle with the whole left side of the big triangle. Okay, so if it's okay with everybody, I'll find GC first. So we're going to go back to middle school where we have to separate these two triangles. I've got the left 14.4, which I need to compare with the 19.2, the left of the big triangle. And I'm going to compare GC, which is the right of the small, to the 21, which is the right of the big. So I'm not even going to worry about this 4.8 and this unknown CH yet. I'll get to it in just a minute. So left with the big left, right with the big right. So this is more of a middle school problem to get GC. It becomes a high school issue to get CH. Okay, so here we go. 14.4, which is the left side of the small triangle. It's going to go with the 19.2. And again, I got that by adding these two little sections together. And that's the left side of the big triangle. GC, which is the right side of the small, is going to be compared to the right side of the big, and that's 21. We're going to cross multiply and solve. So I'm going to multiply 19.2 times GC and 14.4 times 21. And then I'm going to divide by 19.2. So we're going to cross multiply here. So 19.2 times GC. One of these days I'm going to learn how to write smaller with this little sucker. And then 14.4 times 21. And that's going to be 302.4. All right, and the opposite is to divide by 19.2. That's going to let me get what GC is. So take 302.4, divide by 19.2, and this is going to get you what GC is, and you should be looking at 15.75. So 15.75. And my students ask me all the time, can you get decimals? Of course you can. You guys, out in the real world, if you were to ever use this, and there are certain jobs that will, you should be alarmed if you get a nice number like 15 or 16, because that should probably tip you off if something ain't right. All right, so we got GC is 15.75. 15.75. Okay, now we're into the high school part where I have 3 of the sections, and I need to find this little section right here because the lines are parallel. We can say 14.4 over 4.8, left with left. equals 15.75 over the unknown, right with right. So left goes with left, right goes with right. And again, I can only do that if the lines are parallel, and they are. So I'm going to erase this right here. And I'm going to do our nifty little shortcut for the high school. Left with left, right with right. Now that I have the right part. So 14.4 over 4.8. Left with left. And I'm going to do right with right. 15.75 over that unknown, which I'm going to call CH, so you guys don't get confused of what I'm trying to solve for. I'm trying to solve this little section right here. All right, cross, multiply, and solve. So 14.4 times the CH. And 4.8 times 15.75. And that's going to be 75.6. All right, the opposite of multiplying is to divide by 14.4. So we're going to divide by 14.4 to the other side. Of course, we're going to cross off over here. So CH, so it's going to end up being 5.25. All right, there's your check. All right, so it looks like I'm done with page 487 on your workbook. So we're going to turn the page, go to example number 2. All right. Oh, okay, interesting. All right, let me get rid of this. Hope you guys are doing okay. All right. Okay, so it looks like this one is done for us. Might be a little kind of hard to understand, though, because, I mean, I can see where this right here is a little bit weird because the 4 times. All right, we got triangle WXY, and it says Y to L is 5. It says L to X is 20. It says JX is 4 times as long as WJ. They don't tell us what to call it, so that'll be my unknown. And again, JX is 4 times as much, so it'll be 4X. All right, what they're asking us is if the lines are parallel. So it's going back to that rule. Well, they had to be in proportion to each other to be parallel lines. This is the converse that I was talking about earlier. So all they do is they take these little sides and compare them to see if they come out to be the same proportion. Ratio. Ratio is just a comparison of two numbers. So what they did is they said, okay, well, I'm going to take 5. I'm going to divide it by 20. And when they simplify that fraction, they get 1/4. So they're going to take x and they're going to compare it to 4 over 4x. And when the x's cancel out, you're left with a 1/4. And since they are the same ratio, these lines are parallel to each other. So if you ever see this on the ACT, these weird looking triangle thingies, it means the lines are parallel. So they are the same proportion. Voila, they are parallel lines. So the answer is yes. They're parallel. All right, so we got a check down here. And they're probably going to ask us the same type thing. Come on. Move for me. Oh, I guess that's the bottom of the page. Yep, that's the bottom of the page. Okay, don't move for me then. Okay, so let's do this. All right, we got triangle PQR, PQR. All right, PK is 34. All right, we got KQ is 20. Now, those are the two numbers we're going to be comparing because they're on the same side here on the top. PJ is 1.7 of JR. So JR is going to be my X. And then PJ is 1.7X. Y'all, the hardest part about geometry is reading this stuff. So be careful. Watch that right there. All right, so they want to know if these two lines, QR and KJ, are parallel. Well, they have to be in proportion to each other for that to happen. So we're going to take 20. And we're going to divide by 34 to see what that's going to be. So you might want to grab a calculator if you're not good at simplifying fractions. and some people are not. But I can divide these both by 2 because they're even. So 20 divided by 2 is 10. And 34 divided by 2 is a 17. And that's as far as it goes because 17 is what we call a prime number, even though 10 is composite. All right, so I'm going to do the same thing over here. X over 1.7x. Well, of course, the x's are going to cancel out. And again, if you are not, comfortable with dividing 1 by 1.7, grab yourself a calculator. And again, that's going to be 10 over 17. So they are the same thing. And since these are the same proportion, 10 over 17 and 10 over 17, are they parallel? Yes, they are. If they come out to be the same, they're parallel. If they come out to be different, they're not. They are not parallel. All right, so we are done with that check on page 488. All right, so I'm going to get out of this and mosey on to the next page in this, and then it's not going to let me do it. All right, so I'm going to have to get completely out of this for some reason. All right, no worries. Go to the next page. Okay, we got some rules here. Oh, mid-segments. Oh, gosh, y'all, I love mid-segments. Mid-segments are easy. It goes back to being like midpoint. Midpoint, is when you, for ordered pairs, you add them up and you divide by 2. When you get into circles, you've got what's called an inscribed angle. You just take the arc and divide by 2. Mid-segments are easy. You take the segment of the big triangle, divide by 2 to find its mid-segment. Or you can do vice versa. If you have its mid-segment, you can multiply by 2 to get the side of the triangle that's parallel to it. Okay, so with that being said, if you're sitting there completely lost of what I just said, and because you're a visual person, this is it right here. FG is the side of a triangle. Its parallel JK is a mid-segment. I know that because it is bisecting HG side. See how they're marked equal to each other? And it's bisecting FH side. And again, see how these two segments are marked equal to each other, the 2 slash and the 2 slash. That makes JK a mid-segment. JK is half of FG. And vice versa, FG is double JK. So let's say JK is a 5, double it, 5 times 2, FG is 10. And again, vice versa. Let's say that FG is, 50. Then JK would be half that, which is 25. Nice little rule. Okay, so if you've got parallel lines cut by transversals, that means these are in proportion to each other as well. So AB will be with BC, that left goes with left. EF will be with FG, right goes with right. And again, you can cross multiply and solve these. So nice little rule there for proportional parts of parallel lines. And vice versa, if they are marked equal to each other, so like AB is marked equal to BC, EF will also be with FG, and that means that these lines are parallel. That's what these little weird looking triangles are. All right, let's get into it. Y'all, these are easy. If you can just match up things, either you got to divide by 2 or you're going to multiply by 2. So what I'm saying is this. AC is the side of a triangle. See how DE looks like it's parallel to it? It is because these are mid-segments. See how they're marked equal? So D is the bisector of AB. E is the bisector of CB because they're marked equal. That means DE being parallel to AC is half. That means it's going to be half of AC. And since AC is 15, half of 15 is, well, divide by 2, 7.5. There it is. There's example number 3. All right, we got to check here. Okay. So I need to find a bunch of stuff. Okay, now this time, you guys, they gave us mid-segments. It says the FG is a midsegment of AB, which means you need to double 19.5 to AB. So let's do that. I mean, we're right here, so might as well. 19.5 times 2 is going to give me AB. So what is 19.5 times 2? That should be 39. So AB is 39. All right, if FH is 14, then we're going to double it to get CB. Because if FH is a midsegment, it is half of what CB is. So 14 times 2 is going to be 28. All right, and last but not least, GH is 16.25. It is a midsegment of CA. That means we got to take 16.25 times 2 to get CA, or AC. They call it AC over here. And that's going to be 32.5. All right, what else do they want? They want AH. Oh, guys, this is easy. If FG is 19.5 and I multiplied times 2, I doubled it to get AB, and AB is 39. All you got to do is half that again to get AH and BH. What I'm saying is this. If F to H is 19.5, so is AH, so is BH. All three are 19.5. That means AH is 19.5. So is BH, by the way. All right, they want CG. And a while ago I said CB is 28. That means C to G is 14 and B to G is 14. F to H is 14. So will CG and GB there are going to be 14. So not much really to do there. This just is what it is. All right. Looks like I'm done with page 489 of your workbook. Turn to your last page, page 490 of your workbook. I'm on example number 4. Okay. Looks like they set this one up for us, which is super nice. A developer is looking to purchase lots of 18 and 19 on the lake and wants to determine the lengths of the property's boundary that runs along the lake, a measurement known as frontage. By the way, if you're buying real estate, frontage lots are way more expensive than other lots. Find the lake frontage for lot 18 to the nearest tenth of a foot. Tenth is one number after the decimal. All right, so it gives us the rule that allows us to do this. But basically, if their lines are parallel and these are, remember, left can go with left, right can go with right. That's what the rule says. If the lines are parallel, and we're going to cross multiply and solve. So 96.5 will go with 102, and that's what they did right here. X will go with the 120, and that's what they did right there. And then they're going to cross multiply and solve. So 102 will multiply times X. 120 will multiply by 96.5. And then you're going to divide by 102, which is what they did, divide by 102. All right, so we're going to grab our calculators. Looks like we're going to get 113.529, but they want it to the nearest tenth. That means the, oops, my bad, 529. The 2 that's behind the 5 does not change the 5. So it's going to be 113.5. All right, so we are done with, what was that, example number 4? We're done with example number 4. All right, to the bottom of the page, example number 5. All right, I see the lines are marked parallel, which means the rule is these are equal to each other. So I could put JK equal to KL, and over on the left side, I can put AB equal to BC. And it looks like that's what they did to find X. So we're going to put 2x plus 8, my bad, 2x plus 8 equals 7x minus 12. 7x minus 12. All right, we are then going to, looks like they subtract 2x to the other side. Well, minus 2x, 7x minus 2x is 5x. Then they're going to add 12 to the other side, and that means that 8 plus 12 is a 20. equals 5x, and the opposite of multiplying by 5 is to divide by 5, and 20 divided by 5 is a 4. We got x equals 4. All right, same thing for our y over here. They're going to put 4y minus 1 equal to the y plus 8. All right, there we go. And looks like we're going to subtract y to the other side. So 4y minus y is 3y. Let's see, that's going to bring down the minus 1 equals 8. We're going to add 1 to the other side. So 8 plus 1 is 9. And then the opposite of multiplying by 3 is to divide by 3. So 9 divided by 3 is a 3. So y is equal to 3. All right. Oh, that's all. Okay, we are done. Whoop, whoop, whoop. All right, if you have any questions, ask your teacher. Please ask me. You got some extra examples online if your teacher gives that to you. And yeah, whoever asked for this, I hope this helps. And yeah, I hope you have a great day. You guys have a good one. All right, bye.